Hey guys, I welcome you all to this session. So today we're going to be doing very interesting. We have a dataset called as Pokemon dataset. We're going to use this dataset and understand how can we draw some inferences from this. So we're going to use some data science and data analytics techniques to actually be a Pokemon trainer. So that's quite intriguing, isn't it? Now before we start off with the session, just give me a confirmation if you guys can see my screen and also if you can hear me properly. And also just tell me how many of you are Pokemon fans over here. Just start off with a quick confirmation, please. Let me just wait for some of you guys to answer. And Now, before we start off with the session and before you guys give me a confirmation, I'd like to inform you folks that we have launched a free learning platform called as Great Learning Academy. And on Great Learning Academy, you have almost 100 courses, and these 100 courses are totally free. So these courses are with respect to artificial intelligence, cloud computing, digital marketing, statistics, and so on. And the best part is these courses have been taught by industry experts. So these are professors who have their PhDs from Ivy League schools such as Stanford, and also we've got professors from NITs and IITs. And also once you complete these courses, you will have a certificate. So you'll have to complete some quizzes, assignments, or projects. And once you complete them, you'll have a course completion certificate. And you can go ahead and upload that certificate onto your LinkedIn profile or onto your resume. And that will be a huge value add to your resume. Right. So, I have got a confirmation from most of you folks over here. That's great. I believe the rest of the folks would join in after a bit of time. In today's session, what we're going to do is we have this Pokemon data set, and primarily we'll be focusing on three types of Pokemons, which would be grass Pokemon, fire Pokemon, and water Pokemon. And we're going to catch some of these Pokemons. Now, when I say catch some of these Pokemons, what I basically mean is from this entire data set, we'll be extracting grass type Pokemons, fire type Pokemons, and water type Pokemons, and understand some of their features. We'll be understanding some features of grass Pokemon, some features of fire Pokemon, and some features of water Pokemon. So now that the agenda is clear, let's go to RStudio. So we'll be performing all of these analytics techniques in RStudio. I hope you guys are comfortable with the R language, and if you guys are not comfortable, then well, I'll try my best to make things as clear as possible. And anyway, you can keep posting your questions in the chat, and I'll parallelly take all of your questions as and when possible. Now, our first task would be to load this dataset, and to load this dataset in R, we have a function called as read.csv. Now, I'll just go ahead and use this command over here. I'll paste this, and with the help of this read.csv, I am loading the pokemon.csv file. This is the entire path. So basically inside this function, I am giving the path of this file, and I am storing this in a new object called as Pokemon. And let me just hit enter. Now I'll have a glance at this dataset, and to have a glance at the dataset, I'd have to use the view method. So inside view, I will pass in the Pokemon data frame. And now these are the different columns which are present over here. So we've got the abilities, which tells us about the abilities of the Pokemon. Then we've got against bug, against dark, against dragon, against electric, and so on. So these columns basically tell us how does a particular Pokemon perform against a bug type Pokemon. How does this Pokemon perform against a dark type Pokemon? Similarly, how does this Pokemon perform against a fairy type Pokemon? So these are some basic inferences over here. Then we've got the defense of the Pokemon. We've got the height of the Pokemon in meters, the HP of the Pokemon. Then over here we've got the special attack, special defense, and speed of the Pokemon. Then we've got type 1 and type 2. So this type 1 is basically the primary type of the Pokemon, and type 2 is the secondary type of the Pokemon. And we've got weight in kg. So this tells us about the weight in kg of the Pokemon. And then we've got 7 generations of these Pokemon. And this final column over here is legendary. This tells us if the Pokemon is legendary or not. So this is some basic information about the Pokemon dataset. Prince Singh is asking, can we have this session in Hindi? Sure. So we'll have a lot more live sessions, and we'll definitely have this session in Hindi as well. Astha is saying she's not comfortable with R. That wouldn't be a problem because I'll be guiding you through how to implement all of these commands properly. Right, and guys, keep posting your questions. I'll take care of all of your questions simultaneously as well. So now that we've understood this dataset properly, let me just go ahead and analyze this dataset. So I'd want to know how many rows and how many columns are present in this dataset. So to know how many rows are present, I would have to use the n row attribute, and inside this I would pass in the name of the data frame, which is Pokemon. And as you guys see, we've got 801 records, or in other words, we have 801 Pokemons in total. And let me also check the number of columns. To check the number of columns, I'd have to use the ncall method. Inside this, again, I'll be passing in the Pokemon data frame, and as you guys see, we've got 41 columns over here. So we've checked the number of rows, number of columns, and now I'd also want to see if there are any missing values present in this data set. So to check if there are any missing values, we've got the s.na method, and inside this I'll just pass in the Pokemon data frame. Now this gives us a bunch of true and false values. So this means that if there is a false value, then there is no null value over there. But on the other hand, if you find a true value somewhere, then it indicates that there is a null value present over there. Now what we have to do is we'll have to sum up all of the true values. When we sum up all of the true values, we'll get the count of total number of missing values in this data frame. So I would have to use this command sum. Inside sum, I'll use the method s.na, and inside that I'll pass in the Pokemon data frame. And as you guys see, we've got 138 null values present in this data frame. So this was some basic understanding of this data frame. Now that is clear, I'd want to understand some of the categorical columns over here. So I hope you guys know what is the difference between a numerical column and a categorical column. So when it comes to a categorical column, it basically consists of different categories. So as you see over here, we've got the type 1 column over here, and we've got different categories over here: grass, fire, water, and so on. Similarly, if I look at the is legendary column, you will have two categories over here, which are 0 and 1. Similarly, in the generation column, you will have 7 categories starting from 1 going on till 7. And when you talk about a numerical variable, so this what you see, SP attack, SP defense, speed, these are numerical variables because you just have continuous numerical values over here. Now, I'll be glancing at some of the categorical columns. So I'd want to know the number of types of Pokemons which are present. So type 1 would basically tell us the primary type of the Pokemon. So what I'll do is I'll use this method called as table. Inside this I will pass in the type 1 column. So here I'll just give Pokemon $type 1, and this would give me the frequency of all of the different primary types which are present. So here as you see, we've got 114 water Pokemons. So out of the 801 Pokemons in total, we've got 114 water Pokemon. So it seems that the maximum number of Pokemons are of water type. Similarly, if we look at this, we see that there are only 18 fairy Pokemons. And if you look at this, there are only 3 flying type Pokemons. So this is the minimum. So the minimum primary type, or the minimum number of Pokemons which belong to one particular primary type is flying. Similarly, if you look at this, we've got only 23 ice type Pokemons. We've got 52 fire type Pokemons, and let's look at grass. So we've got 78 grass type Pokemons. Right, so we're just trying to understand some important features of this Pokemon dataset. And now we've understood this. Now I'd want to know how many Pokemons belong to different generations over here, and for this purpose I'll be passing in the generation column into the table method. So I'll use table. Inside this I'll just type in Pokemon $generation, and as you see, we've got 7 generations of Pokemons, and most of the Pokemons belong to the 5th generation. So we've got 156 Pokemons belonging to the 5th generation, and we've got the next highest is the 1st generation. So we've got 151 Pokemons belonging to the 1st generation. and the least. So the least which you see is the 6th generation. We've got only 72 Pokemons which belonging to the 6th generation. So again, a very interesting observation over here. Right, so these are the sort of inferences which we are trying to draw from this Pokemon data set. Now I'd want to know what is the frequency of number of Pokemons which are legendary and which are also not legendary. And that is why I am passing in the S legendary column into this table method over here. So 0 over here indicates that the Pokemon is not legendary and 1 over here indicates that the Pokemon is legendary. So from this we see that out of the 801 Pokemons, 731 Pokemons are not legendary and it's only 70 Pokemons which are legendary over here. So there are very few legendary Pokemons present. Again, a very interesting observation. Asta is asking in which editor I am coding. So this ID which I am using is known as R Studio, and this is the most widely used ID for R. Hemant is asking, can we get datasets? Yes, to get the datasets, you will actually find the link of the datasets in the description over here. So my team will be adding the link. You can get the code as well as the dataset from that particular link. Koribili Raju is asking why we use Pokemon. So this is just an interesting case study which we've taken up over here, Raju. So what we're doing is we've got this Pokemon dataset which has around 801 Pokemons, and we're just trying to understand what are the different features of different Pokemons. And primarily in this session we'll be focusing on grass, water and fire type Pokemons. Sivakumar is asking, to understand functions and commands, first I'd have to learn R language. You'd have to know basics of R, but then again I'll try to make sure that you guys understand all of these codes as as much as possible. I mean, all of these codes are very intuitive. There's not much difficulty in understanding them. You can also learn R through most of the problem statements or most of the projects, and that is what I'm trying to implement over here. Mohammed is saying, can I use Python? Or absolutely, I can also use Python for my next session. So we'll be having a lot of data science projects. So in this particular session, I am using R. In next session, I'll be using Python. So we'll be covering everything. So guys, keep your requests coming, and also some of you folks who've just joined, I'd inform you guys that if you don't know about Great Learning Academy, we have a free learning platform called as Great Learning Academy, where you have almost 100 courses with respect to different domains such as AI, digital marketing, stats, and so on. And you can go ahead and you can register over there. And also, if you have not yet subscribed to our channel, please go ahead and subscribe to our channel, as it will encourage us to come up with more such live sessions on a regular basis. So guys, go ahead and hit that subscribe button, and also hit that click icon over here, bell icon over there. Sure. So now that we have glanced at some of the categorical columns, let's understand some numerical columns over here. So we've got different numerical columns present in this data set. Now out of all of the numerical columns, I'd want to understand the special attack column. So I'd want to know what is the minimum special attack of a particular Pokemon. So for that, I will use the min method, and inside this I'll just use Pokemon $SP attack, and this is how I'm trying to find out the minimum value of special attack, and we see that the minimum value of special attack is only 10. Now similarly, let me find out the maximum value of special attack. So to find out the maximum value of special attack, I'll use max function, and inside this again I'll pass in the Pokemon data frame, and using the dollar symbol I'll select the column, and the column is again SP attack, and we see that the maximum special attack of a Pokemon is 194. It's interesting observation over here. So minimum special attack of any Pokemon is only 10, and the maximum special attack of a Pokemon is 194. Now similarly, I'd want to know the minimum and maximum values of HP of a Pokemon. So here I'll type in min, and I'll pass in the Pokemon data frame over here, and using the dollar symbol I will select the HP column, and we see that the minimum HP of any Pokemon is 1. And let me also find out the maximum value of HP. So here I'll use max method, and I'll pass in Pokemon, and then I'll use the dollar symbol, I'll select the HP column over here, And as you guys see, the maximum value of HP is 255. Anwar Music is asking, can we get some practice problems? Absolutely. So if you want more practice problems, you can check out Great Learning Academy over there. So I believe my team will add the description for Great Learning Academy over here. Deep Arora is asking, where can I get the dataset? So my team will add the link for the dataset and the code file in the chat over here. So please just wait for my team to update, and you guys will have the link for both the code as well as the dataset over here. Right, and guys, keep posting your questions. I want this session to be as interactive as possible. So we have glanced at the categorical columns and we have also glanced at the numerical columns. So now that this is done, what I'd want to do is I'd want to rename some of my columns over here. So as you guys see, I've got these two columns over here. I've got type 1 column and type 2 column. Now this is not actually right. So type 1 has to be the primary type. It has to be renamed to primary type, and type 2 has to be renamed to secondary type. So let's go ahead and do that. So for that purpose, we have this command over here. Let me just go ahead and paste it, and let me explain what is happening over here. So we have this method called as call names. Now I'll just cut everything over here and let me just print out call names of Pokemon. So when I print out call names of Pokemon, this gives me the list of all of the column names which are present in this data frame. Now that this is done, what I'll do is I am checking call name of Pokemon is double equal to type 1. And here I have a bunch of false and true values, and I have a true value only in that case where the column name is equal to type 1. Now with the help of this entire command, what I'm doing is, let me just copy this again and paste it over here. So what I'm doing is, from this all of the column names, wherever the column name is equal to type 1, I am changing the name of that column to primary type. So this is what we are doing over here. Now let me have a glance at the Pokemon data frame again. I'll type in view of Pokemon. Now let me have a glance at this. So as you see, initially the name of this column is type 1. Now we have successfully changed it to primary type. Similarly, we've got the type 2 column. Let's go ahead and change the name of that column to secondary type over here. So as you see, call names of Pokemon, we've got type 2 over here, and I'd want to change the name of this from type 2 to secondary type. So this is what we are doing, and I'll just have a glance at this again, view of Pokemon, and let's see what is the result over here. I'll just drag this to the end of this data set. And as you guys see, initially the name of this column was type 2. I have successfully changed this to secondary type. So I hope most of you folks are clear. Let me know if there's any confusion anywhere. Asta is asking here, are we analyzing our data, not training it, right? Right. So right now we're just analyzing our data. Training of the data will come when we'll be building some machine learning models. Unban Music is asking, can we put this data in bar graph using matplotlib? Yes, you can absolutely do that. We can go ahead and make a bar plot for this. But when you talk about matplotlib is a library in Python, but we are working with R. So in R, we have a library called as ggplot2, and we'll be using ggplot2 to build some visualization over here. Right. So we have done the basic pre-processing over here. Now we'll go ahead and start our first task. So our first task is to catch some grass type Pokemons. Now when I say that we'd have to catch some grass type Pokemons, what I basically mean is we'd have to extract all of the grass type Pokemons from this primary type column. And to do that, I would need this library called as deployer. So the deployer is a package in R which should help us to do some basic data manipulation. So here I'll go ahead and write this command. So first I'd have to give in the name of the data frame, and from this data frame I'm using the filter method. So filter method is a part of the deployer library. So I'm using this filter method to extract only those Pokemons whose primary type is equal to grass, and I'm storing all of those Pokemons in a new data frame called as grass Pokemon. So I'll repeat this command again. So this, what you see, this is known as the pipe operator, and this pipe operator helps us to connect different data sets or different functions together. So here we are connecting this Pokemon data frame with the filter method. And from this Pokemon data frame, we are filtering out only those Pokemons whose primary type is grass, and we are storing the result in this object called as grass Pokemon. Now we've done that, I'll go ahead and have a glance at this. So I'll use the view method, and inside this I'll pass in grass Pokemon. So we see that there are 78 grass Pokemons in total. Out of the 801 Pokemons, we've got 78 grass Pokemons. And let me look at the primary type. So as you see the primary type over here, so you see that all of these are only grass type. So an interesting observation over here again. Hemant is asking which models am I using for this demonstration. So we'll actually go ahead and use a linear regression algorithm later on in the session, and also we'll go ahead and build a decision tree. Mohammad Hashir is saying, I think Python has much more libraries than R for data science. Well, that is sort of true. When you talk about data science, you have more libraries in Python. But when it comes to EDA, I mostly prefer using R than Python, and also in the industry when it comes to any sort of statistical analysis or performing any sort of EDA, then people go for R rather than Python. And when it comes to deep learning or maybe a general purpose development, that is when people go for Python. Right, so we have extracted this grass type Pokemon over here. Now that this is done, I would have to perform some basic inferences on this grass type Pokemon. So what I'm going to do is I'd want to understand the minimum and maximum speed of a grass type Pokemon. So here I'll use the min method again. I will pass in the grass Pokemon inside this, and let me check the speed of it. So minimum of grass Pokemon $speed, and I see that the minimum speed of a grass Pokemon is only 10. Similarly, I'd want to check the maximum speed of a grass Pokemon. So here I'll pass in grass Pokemon $speed, and I see that the maximum speed of a grass Pokemon is 145. So let me add this as a comment over here. I'll use hash, and the minimum speed is 10 and the maximum speed of a grass type Pokemon is 145. I'll also go ahead and add that. Now similarly, I'd want to check the average value of special attack and special defense for a grass type Pokemon. And to check the average value, I'd have to use the mean method. And inside this, I'll pass in grass Pokemon $special attack. And the average value of special attack for a grass type Pokemon, it comes out to be 74. So let me just add in 74 over here. Similarly, I'll also check the average value for special defense. So grass Pokemon $special defense, and we see that this comes out to be 69. I'll also add 69 over here. So we have glanced at some basic information of the grass type Pokemon. Now it's time to visualize some stats of the grass type Pokemon. So here I'd want to understand the distribution of HP. So HP is basically hyper power of a Pokemon. So I'd want to understand the distribution of hyper power of a grass type Pokemon. And what we'll be doing is we'll be using the ggplot2 library to make this visualization. So I'd have to load this library. So here I'll type in library of ggplot2, and we have loaded this library over here. Now to actually understand the distribution of this HP column, so let me go ahead and show you guys the HP column over here. So let me just check. So as you see, this is the HP column and this is a numerical type of column. And we've understood in the previous sessions that if it's a numerical column, we use a histogram, and if it's a categorical column, we use a bar plot. And since this is a numerical column over here, I will be using a numerical column. So my first task would be to use ggplot, and I'll go ahead and map the Pokemon data onto the data layer. So let me hit enter. As you guys see, I have mapped the Pokemon data frame onto the data layer. Then I'd have to map the column onto the X aesthetic. So I'll add the aesthetic layer over here, and onto the X aesthetic I will map the HP column. Going ahead, I'll use a geometry, and the geometry which I'm using is Histogram, because I don't want to make a histogram obviously, and since this is a numerical column, we have to pick a histogram. And this is what we get over here. Let me zoom this and let's see the distribution of the HP of a grass type Pokemon. So as you guys see, we've got around, so this count is for the number of Pokemons present. So as you guys see, we have around close to maybe 140 Pokemon. So there are around 140 Pokemons whose HP would be around 60, right? And similarly, there would be around 55 odd Pokemons whose HP would be close to 100. And there are very few Pokemon. So maybe there are just 2 or 3 Pokemons whose HP is greater than 200. Now, when you talk about this, we are talking about grass type Pokemons. So we have only 2 grass type Pokemons whose HP is greater than 100. Similarly, there are only 140 grass type Pokemons whose HP would be around 50 to 55. And there are around 55 odd grass type Pokemons whose HP is around 100. So that's an interesting observation over here again. But what you see, this plot is very bland. Now if I want to go ahead and add a color to this, I have an attribute called as fill. And for this fill attribute, I will use pale green 4. And as you guys see, I have successfully added this color over here, which is pale green 4. Let me just go ahead and see if there are any more questions. Mohammad Hashir is asking which is my favorite deep learning algorithm. Are you talking about my favorite deep learning framework? If you talk about my favorite deep learning framework, that would have to be Keras. Favorite deep learning algorithm, that's a very generic question, so I'm not really sure what you mean by this. So also guys, keep posting your questions over here, right? So we have made this histogram over here. Now that this is done, similarly I'd want to understand the distribution of the height of grass type Pokemons. So again, I'd have to go ahead and make a similar plot. So ggplot, onto the data layer I'll be mapping the Pokemon data frame, then I'll have the aesthetic layer, and onto the X aesthetic, this time I'd have to map the height M column, which is basically height of the Pokemon in meters, and again I'd have to make a histogram. Since I'd have to make a histogram, I'd have to use the geom histogram method. And as you guys see, I have made this histogram over here again. Now let me zoom this, and as you guys see over here, the height it varies from 0 to around 15 meters. So when you talk about grass type Pokemons, there is only one grass type Pokemon whose height is very close to 15 meters, and we'll have around 3 grass type Pokemons whose height is maybe 8 or 9 meters, and most of the Pokemons, so we've got around maybe 200 or more than 200 odd Pokemons whose height is around 1 meter or less than that. So that again is interesting observation. So here we've actually made a mistake. So we've plotted just the Pokemon data frame. We have to plot the grass Pokemon over here. So let me go ahead and make this as grass Pokemon. Right. Now this is the actual distribution of a grass type Pokemon. So we see that there are around the maximum height of a grass type Pokemon is actually only 3.5 meters. This again is very interesting. And most of the Pokemons there, as you see, most of them are concentrated over here. Most of the grass type Pokemons, again, their height is less than 1 meter over here. So interesting observation again. Ratul is asking what is the use of aesthetic function. So aesthetic function is basically a layer, and with the help of that layer I'll be mapping different columns onto that layer. So as you see over here, AES, this is a layer in ggplot2, and we can map different columns. So as you see, I am mapping the height column onto the x aesthetic. I am mapping the weight column onto the x aesthetic. Now, till now we've just used X, but we can have other aesthetics as well. We can have Y as an aesthetic, and the size we can map a column onto any importance of aesthetic layer. Now, so this was a basic distribution between some numerical columns. Now we'll go ahead and understand how many of the grass type Pokemons are legendary and how many of the grass type Pokemons are not legendary. And for this purpose, we'll be making a bar plot. So ggplot again, and onto the data layer I'd have to map the grass Pokemon, and I'll use aesthetic layer over here, and onto the x-axis I'll be mapping this legendary column, and the geometry which I'll be using is geom bar. Again, a very interesting observation over here. So the 0 indicates that the grass type Pokemon is not legendary, and the 1 over here indicates that the grass type Pokemon is legendary. And we see that there are 70 odd Pokemons, or close to 70 odd Pokemons, which are not legendary, and there are very few Pokemons, maybe around 5 or 6 Pokemons, 5 or 6 grass type Pokemons, which are actually legendary. So all of this was about grass type Pokemons. Unban Music is asking how can we install ggplot2 package. So to install the ggplot2 package, you'd have to click on this packages tab. You have the install button. You'll get the wizard over here. Now in this wizard, you just have to give in the name of the package, which is ggplot2, and when you click on install, your package will be automatically installed. So as simple as that. So Yash is asking, can I do this in Python? Absolutely, but not in this session. So we'll have a different session later where we'll be performing the same sort of stuff in Python. So we'll have a lot more data science project going ahead. So this is just our first data science project. We have a lot more lined up. So as tomorrow we have the PUBG data analysis lined up. So if you guys are interested, you can go ahead and register for that as well. So this was all about the grass type Pokemon. Now let's go ahead and catch some fire type Pokemons. So when I say let's go ahead and catch some fire type Pokemons, what I mean is we'd have to extract fire type Pokemons out of the original Pokemon dataset. So I'll have view, and let me type in Pokemon over here. Let me look at the primary type. And if I look at the primary type, as you see, we've got all of these different levels over here. And all of these different levels, I want to extract only those Pokemons where the primary type is equal to fire. So this would be the command for that. I'll have Pokemon, I'll use the pipe operator over here. Let me type in the filter command. So the filter command is part of the deployer package, and inside this I need to give in the condition, and the condition is the primary type needs to be equal to fire. And I'll go ahead and store this in a new object, and I'll name that object to be fire Pokemon. And I'll have a glance at this view of fire Pokemon, and as you guys see, we've got 52 fire Pokemons in total. So out of the 801 Pokemons, we've got 52 fire Pokemon. So that's actually very less. Now let me see the primary type. So if you see the primary type, you see that all of the values are fire, because this was the condition which we had given while extracting the data sets. Right, so we've got this done. Now we are going to do a similar sort of analysis over here. So first we'll start up by understanding the minimum and maximum value of a fire type Pokemon. So I'll use the min method over here, and inside this I'll pass in Pokemon. So Pokemon This has to be fire Pokemon actually. So minimum value of fire Pokemon. Minimum, I have to check the speed. So minimum speed of a fire type Pokemon is 20. Let me just add a comment over here. So minimum speed of a fire type Pokemon is 20, and similarly let me check the maximum speed. So here I'll have maximum of fire Pokemon $speed, and we see that the maximum speed of a fire type Pokemon is 159. Now let me go ahead and compare the speed of a fire type Pokemon with that of a grass type Pokemon. So here as you see, the minimum and maximum value of a grass type Pokemon, the speed of a grass type Pokemon are 10 and 145. This is 20 and 159. So it seems that in a general case, if we take only minimum and maximum value, it seems that the fire type Pokemons might have a higher speed when compared to the grass type Pokemons. So an interesting observation over here, isn't it? Hemant is saying, based on the legendary column count, is it not imbalanced 40-70? Yes, it is an imbalanced data set. So for all of those folks who don't know what a balanced or an imbalanced data set is, an imbalanced data set basically means that, let's say if we have two categories, and if we have one amount to be in a larger if we have one category to be in a larger amount and another category to be present in a very small amount, that is called as an imbalanced data set. And right now we are actually dealing with an imbalanced data set over here. So that's a good observation, Hemant. So keep posting your questions over here, guys. I don't see a lot of questions. Keep them coming. And also for those folks who've just joined in, if you haven't yet subscribed to our channel, please go ahead and subscribe to our channel, as we'll be coming up with a lot more live sessions and we'll be uploading a lot more tutorials. And also if you're interested to upskill yourself in this lockdown, you can check out Great Learning Academy over there. So on Great Learning Academy, we've got almost 100 courses, and these courses are with respect to data science, AI, digital marketing, and stats. And once you complete these courses, you will also have a course completion certificate, and you can go ahead and add that certificate onto your resume or onto your LinkedIn profile, which will be a huge value add for you guys. And also, if you let's say if you guys don't have a laptop with you in this lockdown, and if you want to learn through an app, then we also have the Great Learning app with us. So the link for the app will also be present in the description. So you guys can go ahead and download the app as well. Now let's go ahead and do some more inference on our fire type Pokemons. So we have found out the minimum and maximum speed of the fire type Pokemons. Now what we are going to do is we are going to check the average value of special attack and special defense for fire type Pokemons. And to check the average value, we already know that we'd have to use the mean method, and inside this I'll pass in fire Pokemon $SP attack, which will give me the average value of special attack, which is 87. Similarly, let me check the mean value of special defense. So I'd have to use mean. Inside this, I'll pass in 5 Pokemon $SP defense, and as you guys see, the average value of special defense, it comes out to be 71. So we've got 87 and we've got 71 over here. Now let me again compare this with the grass type Pokemon. So the average speed for a fire type Pokemon was 87, and the average attack for the grass type Pokemon is 74. So again, it seems that a fire type Pokemon in general has a higher special attack when it's compared to a grass type Pokemon. Similarly, when we compare the special defense of a fire type Pokemon with a grass type Pokemon, it seems that the fire type Pokemon has a higher value of special defense. So this is an interesting observation over here again. Now we are going to do some visualization on top of the fire type Pokemon to understand some of its stats. So I'd want to understand the frequency of the number of fire Pokemons belonging to different generations, And for that purpose, I'd have to make a bar plot, and I'll be mapping the generation column onto the x-static, or in other words, I want to understand the number of fire Pokemons belonging to different generations over here. So ggplot, this time onto the data layer, instead of mapping the grass type Pokemon, I'll be mapping the fire Pokemon over here, and on the aesthetic layer, I'll be mapping the generation column onto the x aesthetic. And finally, I'd have to make a bar plot, and to make this bar plot, I'll be using geom bar. And when I hit enter over here, I've got all of these bars. So as you see, we've got 7 generations in total. So 1, 2, 3, 4, 5, 6, and 7. And it seems that most of the fire type Pokemons, so it seems that we've got Pokemons which belong to generation 6 to generation 4. So again, this is an interesting observation over here. Dharmendra Kumar is saying it's speed in the last line and not SP attack. Okay, I'll just check that out. So we have this set over here. Right, so now that we have this ready, what I'm going to do is I'm going to understand the frequency of the secondary type of fire type Pokemons. So again, I'll have ggplot over here, and onto the data layer, I'll be mapping fire Pokemon. Then onto the aesthetic layer, I'll be mapping the secondary type column. This actually would go on to the x-axis. So onto the x-axis, I'll be mapping the secondary type column. And again, the geometry which is used by me is geom bar. Let me go ahead and hit enter over here. So seems like I have given a space over here which shouldn't exist. Right. So this again is an interesting plot over here. So as we see, most of the Pokemons, when it comes to fire type, so we've got around 22 odd Pokemons, and these 22 odd Pokemons, they don't really have a secondary type over here. And the next highest is fighting and flying. So it seems like most of the low over here. So as you see, dark, dragon, fire, psychic, rock. So the secondary type of these is very low over here. So this was secondary type. Now so this time I'm going to make a scatter plot. So my first task would be to map the fire Pokemon data frame onto the data layer. Now in the aesthetic layer, I'll be mapping the SP attack on the x-axis. So I have SP attack on the x-axis, and I'd have to map the SP defense onto the y-axis. So I'll have SP defense over here. And since I want to make a scatter plot, I'll be using the geom point method. And let me zoom this over here. So as you guys see, if the special attack of the fire type Pokemon is increasing, the special defense of the fire type Pokemon is also increasing. So you can say that there is sort of a linear relationship between the special attack and special defense of this fire type Pokemon. Right, so that's, if you take this, there is just one Pokemon over here whose special attack and special defense is very low. Right, so this is the only Pokemon whose special attack is only fire type Pokemon whose special attack is less than 40. And again, if we take this particular Pokemon over here, so it seems that there is one fire type Pokemon which has the highest special defense, and this comes out to be around maybe 135 or close to 135. And over here, the special attack value would be close to around 110 maybe. So this again is an interesting observation over here. So this was with respect to special attack and special defense. Now we've got a few more visualizations to do, but we'll just directly head on to water type Pokemon. So let's go ahead and catch some water type Pokemons now. And for this purpose, I'd have to extract all of those Pokemons where the value is water in the primary type column. So first I'll start off by giving the name of the data frame, which is Pokemon, and then I'll use the filter method from the deployer package. Inside this, I'll set the primary type, and this primary type has to be equal to water, and I will store this in a new object, and I'll name that object to be equal to water Pokemon. So I have extracted the water Pokemon as well. Now I'll have a glance at all of these water Pokemon. So view of a water Pokemon, and as you see I have extracted all of the water type Pokemons over here. So we've got 114 water type Pokemon. So out of the 801 entries, we've got 114 water type Pokemons. And as you see the value in this column, all of the values are only water. So now that we have extracted the water type Pokemons, let's do the same analysis over here because I'd want to compare the speed, special attack and special defense with respect to fire and also grass type. I'd want to check the minimum and maximum value of speed. So minimum water Pokemon $speed, and we see that the minimum speed of a water type Pokemon, it comes out to be 5. And also let me check the maximum speed. So here I'll have max water Pokemon $speed, and we see that the maximum speed of a water type Pokemon, it comes out to be 132. Let me compare this with fire type and grass type. So 5 and 132. So seems that water type Pokemon's minimum and maximum speed is less than fire type. Let me check it with what else have we got? We've got grass type over here, and again the minimum and maximum is less than the grass type Pokemon as well. So it seems that the water type Pokemons normally are very slow when compared to grass type and fire type Pokemons. So this is something to ponder upon. So if you want speed, then obviously you will not go ahead and choose a water type Pokemon. You'll probably choose a fire type Pokemon. And now we've found this out. Now what I'm going to do is I will similarly check the average value of special attack and special defense for a water type Pokemon over here. And inside the mean method, I'll have water Pokemon. So water Pokemon $special attack, and it seems that the average value for special attack of a water type Pokemon is 74. And similarly, if I want to check the average value for special defense, so water Pokemon $special defense, this comes out to be 71. And let me check this with respect to grass and fire again. So 74 and 71. So the special defense is same with respect to fire Pokemon, but the special attack is lower when compared to fire. And here, so this was 74. So 74, the special defense is same with respect to grass, and the special defense is actually more when compared to the grass type Pokemon. So this again is an interesting observation over here. So Tech for Future is suggesting us to make 10 tutorials in Hindi also. Yes, we are working on them. So we've got a new team actually, and we are working on a lot more tutorials. So we are making sure that your lockdown is as productive as possible, and we'll be coming up with a lot more live sessions on a regular basis. So let me go ahead and complete the rest of the stuff over here. So we are done with the basic analysis of it. Now I'd want to visualize some stats of a water Pokemon, and I'd want to see how do these water Pokemons perform against ice type Pokemons. So here I've got the against ice column. Let me show you guys the against ice column. This is the column, and what I'm going to do is, since this is actually a continuous numerical value, I'm going to make a histogram for this. So I'll have ggplot, and this time onto the data layer, I'll be mapping the water Pokemon, and onto the aesthetic layer, I'll be mapping the against ice column onto the X aesthetic, and I'll go ahead and make a histogram out of this. So here I'll use geom histogram, and as you guys see over here, so it seems that we've got around 80 odd water Pokemons whose their rating against ice is 0.5, and there are very few Pokemons. There are only around 20 odd water Pokemons whose rating against I is 1. Now similarly, let me check the rating of water type Pokemons against poison type Pokemons. So the command would be same, it's just that instead of mapping against ice onto the X aesthetic, I am mapping against poison onto the X aesthetic over here. So seems like we have got an error. Let me see what exactly is that error over here. Water Pokemon against poison. We have Charm Histogram over here. What I'll do is I would have to type ggplot over here. Right, so it seems that water type Pokemons are better against poison type Pokemons. Now let me compare this with ice. So as you see, with respect to ice type Pokemons, so most of the Pokemons, their average rating was 0.5 against ice type, and over here as you see, most of the Pokemons, most of the water Pokemons, their rating against poison type is 1. And finally, let me see how do these water Pokemons perform against grass type Pokemons. So this time I'll be mapping against grass onto the X aesthetic, and we see that the rating is 2. So we've got 80 odd Pokemons over here this time. So we've got 80 water Pokemons whose rating against grass type is 2, and we've got around 20 odd Pokemons whose rating against grass type is 4. So it seems that the water type Pokemons, they perform very well against grass type Pokemons. That's an interesting observation over here. Right, so guys, we are done with today's session. If you have any doubts, you can post them onto the chat. I'll take them up now. And also, before we sign off, I'd like to inform you guys that we have a free learning platform called as Great Learning Academy, where we have around 100 odd courses, and these 100 odd courses are with respect to domains such as cloud, data science, statistics, digital marketing, and so on. And all of these courses have been taught by instructors who have their PhDs from Ivy League schools such as Stanford and IIT. And once you complete these courses, you will have a certificate, and you can go ahead and add that certificate onto your resume or onto your LinkedIn page. And also, if you want to learn through an app, we also have the GL app. You can find the link for the GL app in the description below. So folks, also do subscribe to our channel. So just go ahead and hit that subscribe button and hit the bell icon. It will encourage us to come up with more such live sessions. So if you enjoyed this session and if you want us to come up with more such sessions, just go ahead and hit that button over there. Now let me see if there are any more questions. And when music is saying I'm in class 10th, but I want to become a data scientist as soon as possible. So how can I do that? Unban, so again, so if you say you want to be a data scientist as soon as possible, you obviously need a degree, that's for sure. So I suggest you, you in your engineering, I suggest you focus a lot more on statistics, and also focus on languages such as Python and R, and learn about algorithms such as linear regression, logistic regression. You've got decision tree, random forest, and so on. So I suggest you focus on all of these, and you will definitely become a data scientist for sure. Priya is asking, while analyzing data, what kind of questions should one keep in mind to make an effective analysis? So that's a very good question. So now normally when you're analyzing the data, your first task should be pre-processing, and when I say pre-processing, you would have to look for any sort of anomalies or missing data. So if any missing data is present, you will go ahead and try to impute that missing data. So most of the common ways is to impute that data with either a mean, But then again, that's a very simple method. So in R, you've got different packages such as mice, you've got Amelia, you've got KNN. So you can use all of these different libraries and impute your missing data. And also, when I talk about anomalies or outliers, that is also something which you'd have to deal with. And also, let's say that be cases where the names of the columns are incorrect, or let's say the values the inside the table is incorrect. That is also something which you'd have to look forward for. Right. So, guys, this is it from my side in this session. Thank you very much for attending, and hope you guys are safe and have a great learning ahead. Thank you very much for joining. I'll end from my side today.